Hey, what's going on, guys? Let's do this problem right here. This question is asking whether this series is absolutely convergent, conditionally convergent, or divergent. So first we start from here. We start from absolutely convergent. If it's not, then we move to conditionally convergent, and if it's not, then it's divergent. And if it's absolutely convergent, we stop right there and say absolutely convergent. So that's how we do these kind of problems. And let's see how we can find whether this is absolutely convergent. The first question is whether this series is absolutely convergent. To check that one, what we do, we take the absolute value of this one. So if we take absolute value, we know that this negative one is going to be just positive one, right? If it's absolute value, it's always going to be positive. So here, no matter what power we get, we always going to have positive one. So this is going to be just n over n plus 5, right? So n is equal to 1 and infinity. And from here we can already see the limit is going to be 1 because we have in the numerator and the denominator n power are same. So the ratio is going to be the limit. So if it's 1, we can go and do the limits for divergence, test for divergence test. So here if you take the limit of this one, n approaches infinity, n over n plus 5, and if we don't get 0, that's automatically it's divergent. So here it's 1, so this is definitely a divergent. So this test, so when we take the absolute value and test, and if we find out this is divergent, this means this is not absolutely convergent, but this may conditionally convergent. So to check that one, what we do, we take the second thing. So this is an alternative series, right? Alternating series. So alternating series, we take the Bn values. So Bn values everything except this negative one. If you check the test with negative one, you will get the same thing. But to make everything easier, we take only this part right here and find whether the limit is 0 and is this a decreasing function. And if it satisfies both, then this is a convergent alternating series. But if it's failed to satisfy one of them, this is a divergent series. So here we took the limit of same thing right here. It's equal to 1. So this is not equal to 0. So this is a divergent alternating series. So here we can write this one to clarify. So alternating series test. So limit n approaches infinity, n over n plus 5, the limit is equal to 1, and that's not equal to 0. So this is again divergent alternating series. So this fails both of them. Therefore, we can conclude this is a divergent series. So this is a divergent series. So this is the answer for the first question. So let's see whether the second one absolutely convergent, conditionally convergent, or divergent. So first thing what we do, we take the absolute value of this one. So here if we take absolute value of this one, we know that negative 1 to the power is anything going to be negative 1 or positive 1, but the absolute value is always going to be positive. So we only take this part right here, 16 power n over 5n. So we are going to have n is equal to 1 to infinity 16 power n over 5 power n. As you can see, this is a geometric series because we have number power n. If we have n power number, that's p series. If we have number power n, that's geometric series. So here we can write this one as n is equal to 1 to infinity 16 over 5 power n. So in a geometric series, if the value is greater than 1, if it's greater than 1, that's divergent. And here you can see this 16 over 5, this is definitely greater than 1. So this is divergent geometric series. So now it's failing to satisfy absolutely convergent situation. Now we have to find whether it is conditionally convergent. So again, as we did before, we take the alternating series test. this is an alternating series, right? Because we have -1 power n, so this is an alternating series. We do the alternating series test. So when we do alternating series test, we take the bn part, everything except -1. So this is going to be the bn for this one. And if we have to have, in order to be convergent alternating series, it has to be, the limit has to be equal to 0, and it has to be a decreasing function. And let's take the limit of this one and see what we get. So here, alternating test. Okay, so here we are going to have limit n approaches infinity. This value is same as this one, 16/5 altogether power n. So we can write it in that way, 5 power n. So when you put infinity for this n value, this is an infinity, right? Infinity, so not equal to 0. So this is failing to satisfy one of the alternating series test. So this is a divergent alternating series. Divergent. So again, this is not absolutely convergent, conditionally convergent. So this is a divergent series. And that's how we do this kind of problems. I hope you guys find this video helpful. See you next time.